Okay, let me turn on transcript. Boom. Okay. So again, at the end of class, I'm going to hang around, help people try and figure out how to find their grades on my grade site. And that's what you're going to do for me taking roll. You're going to send me your grade. Tonight, I want to put the finishing touches on chapter 4 a little bit, and then jump into chapter 5 as much as we can do. The chapter 5 homework is already up and open if you wanted to start it already. But in chapter 4, one of the big ideas was to find the equation of a line. Okay. And I said that I must give you, okay, the point, a point, and I must give you a slope. I have to give it to you. Have to. There's no way you can do it otherwise. But I reserve the right to hide that information from you. Hide it in the words. Okay. So here's a quickie example of a new kind of line. Okay, it's find the equation of a line that goes through the point, I don't know, 7, -2. I'm just making this up. And is parallel to the line y equals 3/4 x minus 11. Okay, so take a second to write that problem down and look at the work and try to identify what's missing. Okay, so what's missing?
The intersection.
Well, what do I have to give you? I have to give you a point.
Is it a second pair?
What do you mean?
Oh, sorry.
No, that's okay. No, I'm not sure I understand though. Okay, I have to give you a point and I have to give you a slope. I have to. Have I given you a point?
Yeah.
Yeah, that's the point, the ordered pair. Have I given you the slope?
Isn't 3/4 the slope?
Okay, yes, it's hidden inside these words. Inside these words, okay, parallel, okay, means same slope. When two lines are parallel, they have the same slope as each other. Just think about it. Parallel lines, okay, look that way, their slope, their slant is the same. Other parallel lines, look that way, their slopes are the same. So the slope was hidden inside this word parallel. So for this problem, I've given you, okay, I've given you the point and the slope is 3/4. Okay, hidden inside that word. Take a second. This will be a review of what we did last night. Now that we have a point and a slope, can you find the equation of a line? So I'll pause, give you a minute to look at last night's notes. So last night, I said, start with this formula, y equals mx plus b. Plug in everything we know. Well, we know the y value is -2 equals, we figured out the slope is 3/4. The x is 7 plus what we don't know is what's the b value. Okay, so I said, start with a formula, plug in the slope of the point, everything we know into that formula, solve for B. That's going to be the messy part. And this is where I told you use your calculator. So real quick, this is going to be -2 equals 21 over 4 plus B, because you can go 3 times 7 over 4. Okay, you're going to use your calculator to take away 21/4 from both sides. Okay. And I get -29/4 is B. Can anybody confirm that?
That's what I got.
Okay. All right. So because of that, then we put all this junk back in the formula. Y equals 3/4 X. Whoops, this would be minus 29 over 4. And that is the equation of the line that's parallel to this line. So my new line has the same slope as the old line, but my new line goes through this point where the old line didn't. Okay, that's why it has a different intercept. This is a y-intercept of -11. This is a y-intercept of whatever 29/4 is negative. Okay. So in a minute, I'm going to get questions, but this example was twofold. Number one, I wanted to talk about what the word parallel means. Two lines are parallel, their slopes are the same. So you could just pull that information out. That 3/4 is the slope. You can use it. And then over here, we did a quickie review of how to find the equation of a line using this point and this slope. All right, questions on that? Okay, we are recording. All right, then we're going to move to a slightly different problem. I want the equation of a line that goes through, oh, I don't know, let's say -3, 2. I'm just making up this point, but is perpendicular to y equals 2/5 x plus 7. 2/5. All right. This is trickier. I'm not going to have you work on it. I want to explain what it means. Okay. First off, the word perpendicular here means the lines cross at right angles to each other. When the two lines cross, two lines are perpendicular. Okay. When they cross each other, they make a 90-degree angle, a right angle. That's what the word perpendicular means. Cross at a 90-degree angle. Okay, this is kind of awkward. Okay, the slopes are opposite reciprocals. Of each other. Now I'll explain what that means. Okay, there are two things here. Opposite. Opposite means one of them is positive, one of them is negative. That's what the word opposite means. Positive, negative. So if my first slope is positive, its reciprocal, its perpendicular will be negative. And the reciprocal means flip it over. So let me give you some quickie examples here. So suppose I have a line number 1 okay, and its slope is 3/4. Okay, then it's perpendicular, and this is the symbol we write for perpendicular. You don't need to know it, but we use it all the time. You just, if I use it, ask me. The perpendicular to it is opposite. So this is positive, this is negative, reciprocal 4/3. So if I have a line that has a slope of 3/4, then another line that's perpendicular to it that meets at a 90-degree angle, its slope is guaranteed to be -4/3, the opposite reciprocal of that one. They're the opposite reciprocal of each other. If I have, let's take another example. Let's say I have a slope for the line of -3/7. Some line somewhere, I don't know where the heck it is, its slope is -3/7. What would its perpendicular slope be? Anybody?
7/3.
7/3.
Okay, I'm going to stress the positive 7/3. You don't have to put the plus there, but I'm going to, because I want to emphasize the switch from negative to positive. But you're right. Okay, so what if I have another one where my slope is 3? What is my perpendicular slope?
-1/3.
-1/3.
Good. Okay, so for perpendicular lines, we have to work a little bit harder. Parallel lines are a piece of cake. Oh, you just take the slope and use it. Perpendicular lines, we got to think a little bit more. So your thinking is something like this. Okay. Okay, my thinking is something like this. Perpendicular. The slope right now is 2/5. But the problem says, no. You've got to use the perpendicular. So the perpendicular slope that I want to use would be what?
-5/2.
Yep. Okay, so this is the slope of this line, but because the problem says use the perpendicular, we're going to use this number instead. Okay, so go ahead and find the equation of a line that goes through this point and uses this slope. Look where I'm pointing, this -5/2 slope. Okay, so I'll pause while you guys do that work. Excuse me. Okay, so I did a lot of arithmetic in my head. Please double check, make sure I did it right. Okay. I got -11/2 for my B value. Can anyone confirm that? -11/2? Okay. All right. So then plugging everybody in, that should be your new equation. This equation is perpendicular to this equation. And the new equation will go through that point. Okay. This equation is perpendicular to the original equation because their slopes are opposite reciprocals. But we had to do more work because it now needs to go through a different point, and it does, it's guaranteed to. All right, so that's the concept of parallel and perpendicular. I do know that there's a few questions in MOM that ask about, are these lines parallel or perpendicular or neither? Okay, and all you have to do is figure out the slopes. If the slopes are equal, they're parallel. If the slopes are opposite reciprocals, they're perpendicular. If they're nothing, I mean, if they're not related in any way, then they're nothing. They're just lines.
How did you get the 11?
Well, okay. How did I, or how should you? I just, on my calculator, I just did 2 take away 15 over 2. Now, how
Oh,
did
okay,
I?
got it, got it.
Okay.
I see what you're saying.
What I'm doing in my head real quick is I know that to subtract fractions or add fractions, you have to get a common denominator. Okay, so what I'm doing mentally is I'm multiplying this fraction by 2 over 2. So I'm getting 4 over 2, take away 15 over 2. So 4 take away 15 is negative 11 over 2. That's what I'm doing. So I'm saying, okay, got to get a common denominator. It's 2, so top and bottom times 2. That's where I got 4. 4 take away 15 was negative 11. That's what I'm doing up here. So it's no magic. Okay, I'm just too lazy to put it in my calculator. You guys, because your grade depends on it, you should be using your calculators. Anybody else? Other questions? Okay. Then this is a trick question. Okay, I'm done with parallel and perpendicular. You're going to have to try some of the homework and then yell and scream at me over the weekend or next week or whatever when you get there and you don't remember it. Okay, but there's going to be a couple questions regarding, just like I wrote up here, find the equation of a line parallel to something or find the equation perpendicular to something. Okay, but this time for a new example, I want you to find the equation of the line that passes through 4 comma negative 1 and 4 comma 3. And I'll let you work on that. So if you looked at last night's work, I gave you a problem very similar to this. And we looked at it, we said, well, I have 2 points. I'm missing a slope. There's no slope. So you go, oh, but I have a slope formula. I have this. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I can find the slope. And then I can go do that junk over there. Cool. So you go y2, which is 3 minus a negative 1 over 4 minus 4. So that gives me 4 over 0, which is undefined. My slope is undefined. But I didn't ask for the slope. And by the way, there were some homework problems in MOM where she asked for the slope here. Okay, and you came up with either undefined, or I think she writes UND, or maybe DNE, one of those two. Whenever you have a zero in the denominator of a fraction, always it's undefined or does not exist. Okay, but that's not what the problem asks me to do. The problem says find the equation of the line. It doesn't say find the slope. I mean, we need to, okay, but we can't. So this is what you should be thinking. This is where the WTF comes in. Okay, and it's another Foster trick. And when I write that, I mean you need to think. Think. There's not really a mathematical way. In other words, you can't just use these formulas and say, okay, there's a formula that'll give you the answer. No, this is a problem that's going to cause you to think before you get the answer. So my thinking is I'm going to sketch a graph. Okay, I already know it's screwed up. I already know it's a trick problem. So I got to think, okay, think of Foster. So I'm going to graph these. I'm going to sketch it. And it's going to go through 4, -1. 1, 2, 3, 4, -1. And it's going to go to 4, 3. So there's the line that goes through those points. It's a vertical line. Its slope is undefined. D and E does not exist, whatever. But it wants the equation of that line. See, there's a difference, guys, and you got to pick up on this. The equation for the slope is different than the equation of the line. They're related to each other, but they're not the same. Okay? The equation for the slope, the value of the slope, is related to the value of the line, but they're not the same. The equation of the line uses the slope, usually. All right, well, let's look at this. I'm not preaching on my part. What do you see these dots have in common?
X
Is what?
4.
4. Therefore, this is the line where x equals 4. That's the answer to this problem. By sketching it, studying those points, I go, whoa, x is 4. Every point on this line, even if I made up someone, this is 4, -7. Okay. Oh, this might be, oh, well, up here, let's go up here. This might be 4,17. Every point on this line, the x value is 4. So its equation is x equals 4, even when its slope was undefined. Okay, so you can't just blindly do math, plug it into the formula, and I'm done. You got to do some thinking along the way, especially when you run into these impossible situations. Especially when you run into like undefined slopes or no solutions. Those are weird. You got to stop and think. Okay, and I know that there's a question similar to this in Mom. Okay, questions on this line, on this problem? No? Okay, so plant that somewhere in the back of your mind. When you're doing your mom homework, this will show up. I guarantee it. Okay, and right there where you have an undefined value, that's where you stop, slow down, and think your way through the problem. Go out of the box. Attack it in a different method. All right, so that's now I've covered equations of lines, finding the equations of lines. Last night we did all the normal stuff. Okay, tonight we tacked onto it some of the weird stuff, parallel lines, perpendicular lines, and just weird WTF lines. Okay, where the slope was just really weird and you had to think yourself through the rest of the problem. Any questions on that? Okay, one more thing before we move into chapter 5. And one of the things we did last night was we sketched inequalities. And those required our lines to be either dotted or solid. They required shading. So I want to review that real quick, and then I want to try and trick you. Don't you just love it? So, as a quickie review, I want you to graph 2x minus, okay, I'll be nice, minus y equals, no, is less than 6. 2x minus y is less than 6. That's pretty normal. Your notes from last night should be able to deal. Okay, so I hesitate to do this, but it's important that you guys have multiple methods to attack a problem. One of the things I said last night was pretend that's an equal sign. So then my question is, how would I graph that? And I am a real big proponent of using an XY table. If X is 0, Y is -6. How did I get that? If X is 0, this drops out of the problem. The 2x will fall out because 2 times 0 is 0. It's gone. So if I have -y equals 6, that implies positive y equals -6. Now I can show you the math of that in a minute. I'll come back. Okay. Or if y is 0, then that part of it drops out. And I have in my head 2x equals 6, which means x is 3. So very quickly, okay, if I wasn't up here talking so much and babbling and on and on and on, we could have gotten those intercept points. We could graph them. 0, -6 is right about there. Roughly 3, 0 is right about there. And I'm ready to draw the line. Now, I understand it could be done a different way, and I'll do it a different way in a moment. I know many of you want to put this into slope intercept and use the rise over run and all that stuff. That's fine. But what I was trying to force last night and force in this example is use what the problem gives you. If the problem gives you an equation in standard form, then build a table of values with the intercepts. It's easier, faster. Okay. All right. So anyway, I'm here. I've got these two intercepts. Do I draw a dotted line or do I draw a solid line?
Dotted.
Dotted.
Because it's less than. Okay. So here I go. Okay. There I am. Dotted. Now I have to determine, do I shade above the line or below the line? And I gave you a trick last night. I said, if the problem is in slope intercept form. If it looks like y is less than mx plus b, mx plus b, or y is greater than mx plus b, if it's in slope intercept form, then you can use the less than or the greater than to tell you where the graph or where to shade. Less than means shade underneath the graph. Greater than means shade above the graph. Okay, but I caution that with a big giant if. Well, this equation is not in slope intercept form. So I tried to show you guys another one. I talked about something called a test point. And that was pick a point anywhere on the whole graph as long as it's not on the line itself. And I tried to encourage you to use 0, 0 as your test point. So you plug it into the original. I'm going to test 0, 0 by plugging 0, 0 into the original. 2 times 0 minus 0 is less than 6. That makes 0 is less than 6. That's true. Well, what that implies is my test point was true. My test point is above the line, so everything above should be true. That's what it says. My test point was true. That means above is true. So I shade up above. Okay. If my test point had been false, then I know above is false, so I would shade below. You can't go wrong with the test point. You can't go wrong with it at all. So anyway, that's the answer. Now, there's a part of me that says, okay, I want you guys all to raise your hand and tell me, okay, who used slope intercept? But on Zoom, raising your hand is a little bit silly. I know, there's a little thingy there that you can do. Would anyone like me to do this same problem using slope intercept instead? Instead of a table of values like I did here, would you rather have me graph it using slope intercept?
Yes.
Yes, please.
Okay, so
What was that one
same
called?
this, well, when you move it like this was called standard form. Okay, standard form. When you have your X's and your Y's on one side equaling a number, that's called standard form. And personally, when I see an equation in standard form, I instantly build a table of values. Because we can cover up, if X is 0, that part drops out. And I can almost solve that little baby problem in my head. And if Y is 0, that part drops out. So I can almost solve the remaining baby problem in my head. Okay, whatever. So let's say we have this same problem, 2x minus y is less than 6. So we're going to take away 2x from both sides. And we're going to get negative y is less than negative 2x plus 6. Now, slope intercept says you have to get y completely alone. You got to get rid of that negative. Okay, you can't, this is a nothing. So you have to divide this side by -1, this side by -1, and -1. But what happens in an inequality when you divide both sides by -1? What happens to that inequality symbol?
Flip it.
Flip it, okay? So you end up with y, flip it, greater than, this reduces to 2x minus 6. Okay, because a negative divided by negative is a positive. Now, with this, my slope is 2 over 1. So I'm going to have rise over run for that. And my y-intercept is 0, -6. So if I plot that and go 0, -6, that's somewhere down here. If I go up 2 over 1, okay, I get the same line as I got here. I go, oops, it's supposed to be dotted, so I make it dotted. Okay, and then lastly, because it's in slope intercept form, y equals mx plus b, okay, I can read the greater than symbol. I can use it. Greater than this line means above this line. So I'm going to shade above. And I get the same thing. Same exact line, same credit on a test or quiz, no matter which way you do it. And that's a quickie review of what we did last night. Now I want to move off of this and show you a couple, they're not trick questions, but they're odd questions. Okay, but I want to make sure that everybody is happy with graphing an inequality. One way or the other, I don't care which way. Everybody's happy with that.
Good.
Good.
Thank
That's
you.
one person that's good. Okay. One person's good. That means all of you are good, right?
Yeah.
Okay. Sarcasm. Doesn't work. It's like trying to use sarcasm in a text message or an email. It never works. Nobody gets it. Okay. So, still talking to, this is chapter 4.7. I'm sorry, if you want to go back and retitle this. The graphing of inequalities, we've gone on. This is chapter 4.7. I'm just kind of reviewing and extending a little bit. Chapter 4.7. Okay, so I want you to graph this one. 2y minus 5 is less than 7. And that is not a mistake. So I'll pause while you guys think about it. Okay, so what we've done consistently when we tried to graph these inequalities is we've pretended that it was an equal sign. And we said, okay, what would I do with an equal sign? Okay, I've done the problem twice. I did it once pretending there's an equal sign there. I've done it a second time with the less than symbol. Okay, I did not flip it because I never divided by a negative number on both sides. So I get this. Now, this is where you go back in your notes. You go something like, there's no X. It's a trick. Okay, there's no X. And I know some of you are sophisticated enough, and this is bringing back math, that you can graph this immediately. Okay, you remember this. Others of you, this is still, you're still struggling. So what this is saying is your Y value is locked in at 6. That's what this is saying. Y is locked in at 6, and X can be anything, 0, 5, -1. It doesn't, I just made up that X could be anything. That's what that's trying to say. When you have an equation, okay, and one variable here, it's saying Y is locked in at that variable, 6, 6, 6, 6, 6. X can be anything you want. So when we plot that, 0, 6, 1, 2, 3, 4, 6. Here's 0, 6, 5, 6. Looks like right about there. -1, 6. Looks like right about there. Okay. I'll put that there. Whatever. So based upon those 3 dots, this looks to me like a horizontal line. The line's going to go horizontally like that. Y equals 6 is a horizontal line. But this is an inequality. It's a dotted horizontal line. Okay, and I have to shade. I have to shade. Okay, several things come up. We went to the normal y equals 6 just to kind of get a feeling where's the line. But we've got to go back and go, oh, but it was an inequality. It was a dotted line. And it was an inequality that required shading. So I have to shade. Y is less than 6. If this is equal to 6, less than would be below it. So I would shade underneath and I'm done.
Can you say that last part again?
I'm done.
How did
Never
you
mind.
figure out that was?
I'm
shade?
sorry. I think I'm funny. Never mind. Apparently I'm not. Because think of what less than means. Smaller than. This line here, it represents the line where x equals 6. Or excuse me, y equals 6. So up here, I would be bigger than 6, greater than 6. Down here, I would be smaller than 6 or less than 6. But because that symbol is a less than, I want to be smaller than 6. That's why I shaded down there.
Can you do the 0, 0 thing and plug in 0, 0?
Yeah, a lot of people don't like that. I will show you that. Okay. Because there's no place to plug in 0 for the x, so we don't do it. And that bothers people, but I'll show you.
But it still works. And I
It
guess
still works, yes. So let's do the same line again. Where are we? We're at 0, 6, sort of like there. 5, 6 is sort of like there, or wherever it is. Dotted line. Okay, so we're still here. Same picture, dotted line, everything. But now we want to test 0, 0 in the original. Okay, this is our test point 0, 0. Remember, if it's true, we shade, okay, towards truth. If it's false, then truth must be on the other side. That's our thinking. Okay, so we plug this 0, 0 in. So we have 2. Does the red show up enough, or do you want me to go to blue?
yeah, it's good. It's good.
Okay, so we have 2 times 0 for y minus 5 is less than 7. The 2 times 0 drops out, so we have minus 5 is less than 7. So that's true. A negative number is always smaller than a positive number. So our test point was true. Our test point was underneath. That must imply everything underneath is true. Okay? Anybody else have any other questions on that one? I will tell you that most of the inequality graphing will be like this, with X's and with Y's. And when you have X's and Y's, it means your line is going to be slanted in some way. But every once in a while, a problem will be missing an X or missing a Y value. And you have to know how to deal with that. Okay, one more of these and we move on to chapter 5. Okay, new example. I want you to graph X greater than or equal to -2. No tricks, no nothing, just graph it. Recording still good. So if we first graph X equals -2, okay, that means X is locked in at -2 and Y can be anything you want, 0, 5, -5, whatever, that doesn't matter. So you plot that, -2, 0, -2, 5, and down here, -2, -5. So with those 3 points, okay, I can see that I think my line is going to be a vertical line. But now I have to decide, is it going to be a dotted line, a dashed line, or is it going to be a solid line? In this case, solid. In this case, because the equal sign, it's going to be solid. Like that. Cool. There it is. There's X. Technically, this is the line X equals -2. Because every X value on it is -2, no matter what. But I also have to shade. I have to decide where to shade on that line. Do I shade to the left of it or do I shade to the right? Well, the way I look at it is I say this in English. X is bigger than, greater than, -2. This is X equals -2. Which way is bigger than -2? That way. X is bigger than -2. That way. So you would shade out here and you'd be done with the problem. That's it. That okay?
Good.
Everybody? Anybody have any questions, hesitations, anything? All right. I want to take about a 5-minute break. 5 minutes, that's all. I need to erase the board when we come back in about 5 minutes. Oh, let's make it 45, 7:45. That's 7 minutes. Okay. Then I want to do a big power push on chapter 5. So I'm going to stop recording. I'm going to erase the board. We'll take about a 7-minute break. All right, we're back. I need to, the first part of tonight's lesson is a whole bunch of just concepts and vocabulary. We will get into actual algebra and actually doing a problem, but we need to set it up first. All right, chapter 5 is all about what are called systems of equations. A system is just a bunch of equations with a bunch of variables. That's all a system is. A bunch of equations and a bunch of variables. We're going to focus on what's called a 2x2 system or a 3x3. That's how you say it, 2x2 or 3x3. What it means is I have two equations and two variables. So two equations, 1, 2, two variables. 3x3 means I have three equations and three variables. Now, supercomputers can deal with systems like of 100 equations and 100 variables. If you want to pay $120 for a calculator, a TI-84 can deal with a system of 15, I think last time I checked, 15 equations, 15 variables. We're going to cover the basics. We're going to stick with these. In business, okay, and in higher level mathematics, they'll use 4x4s or 5x5s or whatever. But they'll also show you other techniques, and a lot of the time they'll use a calculator at that point. My job this semester is to give you the basic skills in solving the system, okay? In other semesters, they'll come back and revisit the idea of the system, and they'll use these basic stuff, but they'll also go beyond it, show you how to use your calculator in different ways. Okay, so a couple things here. Most textbooks, but not all, put this funny brace out here as their way of tying these two equations together. Instead of seeing these as two separate equations in this 2x2 system, by putting the brace out here, you're supposed to go, oh, those are two equations that are part of one big problem. Or, oh, here's three equations that are part of one big problem. That's what the brace out here does, ties it together. Not all textbooks use this, okay, but most do. I do. If you're not sure about what this symbol means on a test or quiz, or even when I'm doing it on the board, always ask me. I'll be happy to explain that to you. Okay, the first thing we need to talk about is what is the solution? First thing we need to talk about is why can't I write? Okay, what is the solution? Okay, it's the values of X, Y, and possibly Z, whatever, that make both equations true at the same time. So let me write a problem up here. Okay, here's an example of a system. We have y equals x minus 2, and we have negative 6x plus 3y equals negative 9. Yeah, okay. All right. Is 3, 1 a solution? That's the first thing that mom is going to be asking you. She's going to give you a system of equations, maybe 3x3, maybe 2x2, and ask, is this a solution? Okay. What that means is if you plug it in, it makes both equations true. So take a second. Is 3, 1 a solution? Notice something important here. 3 is the X value, 1 is the Y value. When you write an ordered pair, always the first number is X. Okay, so the first thing we would do is probably plug it in the top equation. And we, in the top equation, we'd say does 1 equal question mark 3 minus 2? Does 1 equal 3 minus 2? Yes. Okay, so I plugged in 1 for y, 3 for x. Yes. So does that mean 3 comma 1 is a solution to this system?
No,
Anybody?
doesn't it need to?
No.
No,
Okay, you started to say it. Why? Why no? Why yes? Why whatever?
because it doesn't plug into the second equation.
It doesn't make the second equation true.
Well,
Yes. Yeah. Okay, does that make sense to everybody? This 3 comma 1 is a solution to the first line, but when you plug it into the second one, so you get -6 times 3 plus 3 times 1, does it equal question mark -9? So this is -18 plus 3. Does it equal question mark -9? No. And you don't have to do, you could do all this work in your head. I don't care. The answer is either yes or no. Okay. So the answer, is this a solution? No, because even though it made one of the equations true, it didn't make the other one true. And the definition says the solution makes both of the equations true at the same time. Okay, so this is not a solution. Is that okay with everybody? All right, then I want you to try this one. Same system. Okay, but this time I want you to use the ordered pair 1, 1. No, 1, I'm sorry, -1. Use 1, -1. Anybody want to take a shot?
It is solution.
Solution.
It is a solution, yes. Now, if you want me to go through the math, I will, but the answer is yes, because when you plug it in for both, for the top equation, your answer is yes, it makes it true. When you plug it into the bottom equation, it makes it true. So because both of these are true, the answer is yes, it's a solution. Okay, does anybody want to see my arithmetic, or you got to trust me on that?
Trust.
Trust, yeah, okay, fine. That's what got us in trouble in Congress. Okay, this is pretty much it. Well, not quite. For section 5.1, this is a lot of what Mom was going to ask. She'll give you a system of equations, give you an ordered pair, and say, is it a solution, yes or no? So it's a bunch of just plug in and do some junk. Now, I need to give you a little bit of theory here. And I'm going to show it to you graphically. Okay, meaning I'm going to draw a bunch of pictures here. Okay. So when we're graphing, if we want to graph a 2x2 system, we already know that they're going to be straight lines. That's what we've been studying. They're going to be straight lines. There are three situations. If you, okay, graph the lines, okay, one line could go this way. We'll call that line 1. A different line, the other line, could go this way. We'll call that line 2. And so the two lines cross. Okay. And where they cross, whatever that point is your solution. Because it's the one ordered pair, okay, that's on both lines at the same time. It's the point that's on the black line and it's on the green line at the same time. Okay, so if the two straight lines cross, wherever they cross is called your solution. Now, we've talked, okay, we should put it in these funny braces and we should put it in parentheses because that's an ordered pair. And I'm making this up. This looks to me like it's going to be 3, 2. I'm just guessing at that. That's how you show your answer. When you graph the two lines, like if we tried to graph this, okay, I don't want to, but if you try, or by the way, you can go to Desmos and get it to graph things for you quite easily. Okay, if you graph the two lines and if they cross, then this is how you represent the answer. This is it. Okay, what if, okay, here we got two lines again. What's another possibility for graphing of two lines? If they don't cross, what's another possibility then?
They could be parallel.
Good, they could be parallel. So you could have line 1 going like this and line 2 going like this. Okay, and they could be parallel. Okay. Meaning they don't cross. Okay, but wait a minute. We want to know where do they cross. That's what we want. That's the whole point. This point right here is what's on both lines at the same time. It's the solution that's in both of these. So this one, they don't cross. There is no solution. Okay, no solution. Parallel is what you're thinking. Parallel is not the answer. The answer is no solution. Okay, over here, you're thinking, oh, look, they cross. That's not your answer. Your answer is the ordered pair where they cross. Okay, so you need to differentiate between what your thoughts are and what your answer is based upon your thoughts. Now, there's a third possibility when you're graphing two lines that no one ever thinks of. Okay, I just said you can't think of it, and now I'm going to ask anybody think of it. That was pretty stupid of me. There's a third possibility when you're graphing two lines. They're either going to cross, which means they have a solution, or they're not going to cross at all, which means they have no solution. There's a third possibility, and it's weird.
They're gonna cross at 0.
No, because that's still a cross. That would still be the 0, 0. Here, that's still a point. Okay, not an exciting point, but still a point. Anybody want to take a shot?
What
before
is a
Sheree?
line on line?
Yes, okay. A line on another line. What if you had the graph here? And you didn't know this ahead of time, but here's the first line. Here's line 1. And what if it just happened that line 2 was right on top of it? Okay, line 2. Why is my pen dying? I don't know. Let me get another piece of it. Where'd it go? Okay, it just happens that line 2 is right on top of it. Well, this is really, really awkward. Students don't like this possibility. Although it is a very valid possibility, students don't seem to like it very much. Ugh. Ugh, that's not good. Wait a minute, my pen is blowing up. I'm trying to talk and work with a blown up pen. Come on. Oh, that's why it's not writing. It all leaked out. Not good.
Professor, so I have a quick question.
Sure.
So when we're doing our homework and this is on mom, is there basically going to be like 2 lines already there and we just have to find the point with those 2 lines that have already been graphed?
Yes, some of them are going to be that way.
Okay.
Most of the problems, well, okay, we're getting ahead of ourselves. But mom is going to ask you, well, hang on. I just lied to you. Mom is going to give you 2 equations and give you a grid and say, graph these.
Okay.
So you're going to get a score for graphing the lines.
Uh-huh.
And then you're going to get another score for picking the right answer based upon your lines.
Okay.
So
it's
if
like
you
a 2-in-1 problem.
yes.
Okay. Yeah, I just wanted to check because I was like, I didn't know how that would work. You know, there's different ways to go about it.
Right. So you could graph it, and my problem number 1, the 2 lines might cross. And so where it says solution down at the bottom of mom, you put the ordered pair, or however she says. Sometimes she says put the ordered pair. Sometimes she goes right, x equals 3, y equals 2. She's inconsistent, so you got to read the directions.
Okay.
Okay. If on the next problem number 2, you graph the 2 lines and you go, well, they're parallel, then where it says solution down at the bottom, you write no solution, or whatever mom tells you to write. You know, she always puts a little hint here. If there's no solution, write, you know, no solution or whatever she says.
Okay, thank you.
Okay. Now, over here, this one. When the 2 lines happen to be on top of each other, okay, they are literally crossing an infinite number of times. There's an infinite number of points that make both of these lines true at the same time. Okay, so the solution is really, really weird. And it looks like this, and I'm going to have to explain it to you. Now, okay, pretending that I graphed these 2 and this was their graph, they were the same line. Just pretend. Went off, I graphed these 2 lines, here's their graph. Okay, they cross an infinite number of times. Then you're trying to tell the world that any point that makes this equation true makes the other one true. And notice I just picked one of these, whichever one seems easier. You could put the other equation in instead of this one and still get full credit. But this says any ordered pair that makes this equation true also makes the other one true. That's how you read that. And that's a bar there. So any ordered pair that the bar, well, I'm not going to tell you what it means yet. Bar, and then you write one of the equations, and it doesn't matter which one because they're both the same. Okay, so those are the three possibilities when you're graphing. Now, in a few minutes, okay, because I know, okay, how can I put this kindly? Most of us suck at graphing. Okay, that's as kind as I can put it. Because graphing is slow and we don't like it. So we make dumb mistakes. There is going to be a few questions that ask about graphing, but algebra steps, algebra formulas are much more accurate and much quicker, but they require you can't picture the problem. You're just doing a bunch of algebra. But everything we're going to do comes back to these three pictures. Everything comes back to these three situations. Either the line crosses and we get a normal looking answer, or the lines are parallel and we get no solution, meaning they don't cross, that's very important, or they cross an infinite number of times. And so we get a weird solution. I'll explain more about that later. Okay. One last thing, it's in the mom homework and I couldn't take it out. I couldn't take it out of the problems. I couldn't delete them. Okay. When the two lines cross and have an answer, we have some vocabulary words, okay, to describe the situation. And in this case, this is called consistent, independent. And mom will ask you a couple of vocabulary questions like that, okay? And again, like I said, I'm not going to ask any questions on my quizzes or my exams, but it's in the mom homework and I couldn't take it out of it. I couldn't figure out how to delete it from the homework problem without deleting the entire problem. So consistent means there's an answer. Independent describes the direction of the lines. The lines are going off on their own direction. They got nothing to do with each other. One goes one way, one goes the other. They happen to cross. Great. Consistent means there's an answer. Independent means the lines go everywhere. Okay. This has no solution, so it's called inconsistent. That's just it. Inconsistent. No solution, inconsistent. Okay. This has an answer. So it's consistent. But the lines, where one line goes, the other line goes. The lines depend upon each other. Okay, the two lines, because they're the same line, they are dependent. Again, a little bit of vocabulary in mom, and to be really honest, it's in most algebra textbooks. Okay, of all the things I like to test, that's not one of them. But it is in every single algebra textbook. the vocabulary of what is consistent, independent, what is inconsistent, and what is consistent, dependent. Again, the word consistent means there is an answer. If they're independent, that means one line is going one way, one line is going the other, but there is a point, a single point of answer, intersection answer, consistent, independent. If the two lines are actually the same, there's an answer. In fact, there's about 1 billion answers, but they're the same line, so they depend upon each other, so we call it consistent dependent. And then inconsistent means there is no answer. All right, so I am not going to do a graphing problem. You can do graphing, but in the back of your mind, you're thinking of these 3 pictures with these types of answers. If they cross once, there's your solution. If they're parallel, you say no solution. If they're the same line, happen to be on top of each other, then you come up with some weird one. Mom will tell you how to express your answer. She will say that in the directions. Okay, I need to erase. This is all in section 5.1, all of this. Okay. What is a solution and the types of graphs? Any questions on that? Anybody? Okay, I'm going to pause the recording while I erase. Crap, I forgot to record all this. Okay, so I'm going to repeat real quick. So substitution, pick one equation, solve for a variable. That was already solved. Yay. Substitute this variable into the other equation. So I put x minus 2 in place of y because they're the same. Solve the new equation. So all of this was solving. Okay, we got x is 1. Plug in to find the other one. So when we got x is 1, we plug it into the top or bottom to find the other variable. We got y was -1 after plugging in. Okay, the question was, my question was, which picture was it? Was it the first picture that had the lines crossing? Was it the second picture that had the lines parallel? Was it the third picture that had the lines on top of each other? Because you have normal answers, it's going to be that first picture where the lines are crossing, and this is the point where they cross. Okay, and it's all because you just got normal answers. X is 1, y is -1. Is that okay? I cut you off a little bit, but I remember that I hadn't recorded this, and I wanted to record it and answer your question at the same time. So are you okay or not okay? All right, let's move on then. Let's try another one. Okay, you guys try this one. Somebody remind me to turn on the damn recorder in a minute. System 2x minus 3y equals -11, and x minus 4y equals -3. So I want you to use substitution to solve this system. Okay, so pick one of the equations, solve for any variable. But remember, you're a mathematician, that means you're lazy. So which variable will be easiest to get alone? I think it's easiest to get x in the second equation alone. Okay, so I'm going to take this. You guys agree with that or not?
Yeah.
Yes.
Yeah,
Yes.
okay.
Yeah.
So I'm gonna take the second equation, add 4y to both sides. And I'm gonna get x equals 4y minus 3. Okay, so pick one equation, get a variable alone, x. And then I'm going to put that x into the other equation. So I'm going to put all of this in place of x. So I have 2 parentheses, 4y minus 3 minus another 3y equals negative 11. So I plugged 4y minus 3 in place of the x, so that 2 times all of that mess. Again, now we're back to chapter 2 where we're going to distribute. So we have 8y minus 6 minus 3y equals negative 11. Combine like terms, 8 take away 3 is 5y minus 6 equals negative 11. Am I in the glare? Yes. Add 6 to both sides, so I get 5y equals negative 5. Divide y equals negative 1. So I am skipping steps. Okay, and if you need me to show you what I'm doing, I'll be happy to. But I got y is negative 1. Since it's normal, negative 1 is a good answer. I know this is back at that first picture. I know that this would be 2 lines crossing, but I have to find x. Now, let me show you a shortcut here. You can plug this into here, or here, or here. This problem is just a variation of this equation. These 2 equations are the same as each other. Okay, I just manipulated it a little bit. I would plug it into here because it says x equals this answer. So if y is negative 1, x equals this answer if I plug in negative 1. That's my personal opinion. Okay, so x equals 4 times negative 1 for that, minus 3. That would be negative 7, I believe. Let me check my notes. Is that right? Y is negative 1. X equals. Yeah, did you guys get negative 7 or not?
Yes.
Okay, so this is my x, this is my y's. So I know my answer is the solution of, okay, the point negative 7 comma negative 1. Okay or not okay? All right. By the way, you could check your work. You could go off to Desmos, graph each of these lines, and use your mouse to trace where do they cross. And it'll show you, and it should be at this point. Unless I really screwed up somehow, but okay. All right, I want to move on to the last topic for the night. We're not going to get all the way through it, but it'll be enough to give us a start tonight, and then we'll finish it off tomorrow. This is called substitution, section 5.2. We're solving a system using the substitution method. Okay, we're replacing equals with equals. Any questions about this? Okay, then next topic is section 5.3. Okay. I'll get the rest of this in a minute. All right. In chapter 5.3, we're solving the system using what's called addition, elimination. Okay, and I'm going to add with multiplication, and you'll see why in a minute. Okay, mom and modern textbooks just call this the elimination method. But if you go back 10, 15 years, it's called addition elimination method with multiplication. That's the full name. Why? Because it uses all of those. Okay. You have to. Does anybody play chess? In chess, if you play correctly, and let me point out that my 9-year-old daughter can almost beat me, not daughter, granddaughter, she can almost beat me. So that obviously she's either really smart or I don't know how to play, but that's another story. You're supposed to think 2 or 3 steps ahead. You don't make just a move, just in a reaction. You're supposed to think your moves out and ask what would happen 2 or 3 steps into the future. Okay. Well, what's going to happen here is we want, now this is just a quickie example, I'm going to erase it. But what we want is an equation that looks like this. I don't know, 9, I'll do that. 3x minus 2y equals 7, 5x plus 2y, that's an equals 9. Okay, because when I add these two together, what happens with the minus 2y and the plus 2y? That's the key to this whole thing. I want to manipulate my variables, and I'll show you how in a minute, so that when I add them together, one of the variables drops out. That means is eliminated. So I get 8x equals 16 here, which is easy to solve. That means x is worth 2. But the key was I need to look a few steps into the future, and I'll show you how in a minute, okay? So that when eventually I do add these two equations together, one of the variables drops out. Why? Because one's a positive number and one's a negative number. -2 and +2 make 0 y's, which means the y's drop out. That's what you're looking for. That's what you're seeing in the future. So here we go. Let's just do a problem. Or let me give you some steps first, I guess. Okay, first, we're going to multiply 1 or both, it doesn't matter, equation by some magic number. Okay. Step 2, so that when you add a variable drops out. Okay, that's the main steps. Okay, the key is what's this magic number bit? Sure as hell doesn't sound like math. Okay, and the magic number makes opposites. So I'll show you what we're gonna do here. Examples. Okay, 2x, yeah, okay, 2x plus y equals 6, and 3x plus 4y equals 4. Okay. I'm going to show you the lazy way, and then we're going to talk about alternate ways that are just as good. So I have to pick a number out of thin air, and I either have to multiply everything in this equation by that number or everything in this equation by another number, it doesn't matter. So that if I add these two together, some variable will be dropped out. Now, there's a bunch of ways to do this, but I'm just going to simply show you. If I multiply this equation by -4, then this will become a -4y. This will become a positive 4y, or this is a positive 4y. And when I add them together, a -4 and a positive 4 get eliminated. They get dropped out. So what happens? If I multiply everything by -4, I get -8x minus 4y equals -24. So I took the top equation, multiplied everything by -4. -4 times 2 is -8. -4 times y is -4y. -4 times 6 is -24. I'm going to leave the bottom equation alone. So I'm going to leave it as 3x plus 4y equals 4. Okay. Going to add these two together. This makes -5x equals -20. And notice the y's, because they're the opposite of each other, they dropped out. Okay. Solve, divide both sides by -5. And that gives me x is 4. Okay, well, that's a normal answer. So that means there's got to be a y value. Well, once again, I have to plug it back into the original problem to find the other variable. I found x is 4. I plug it back in. I don't know, top one? Maybe? I don't know. We'll see what happens. So if x is 4, I have 2 times 4 plus y equals 6. I'm plugging it into the top equation. So that's 8 plus y equals 6. If I take away 8 from both sides, I get y is -2. So I get these two answers. That means the lines crossed at 4, -2. That was their crossing point. Okay, there's at least 2 more ways that I can think of this problem could be done. But in my opinion, this is the simplest way of using addition elimination. I multiplied the top equation by some number. Now, it wasn't magic and it wasn't random. What I was running through was my multiplication tables real quick in my head. Okay, how can I make some of these numbers the opposite of each other? One positive, one negative. And it seemed to me that by multiplying by -4, okay, that was the easiest one. But I have to multiply everybody in that equation by -4. Questions?
So you got that -4 from equals 4 and you just did the opposite?
Yeah.
Okay.
No, wait a minute. From this 4, or from this 4.
Oh, no, the equals 4.
No, this 4. I just did the opposite of it. Because
Okay.
I remember I want to make either the X's or the Y's drop out.
Mhm.
So it's the X's and Y's that I'm focused on, not these numbers over here.
Oh, okay.
Okay, so I saw a positive 4 here where I'm pointing. So I said, oh, I can make that into a negative 4, and then they'll drop out. No, yes, no, maybe.
Yeah, I'm just writing it down.
Okay. Anybody else? Can anybody see a different way that this problem could have been done? Not a better way, just a different way. Okay.
Multiply everything by 12
Um,
or by a common denominator?
well, but there is no denominator in this one.
Or, I mean, I'm sorry, least common. No, never mind. I don't know.
Multiple. Okay,
Multiple,
okay.
yeah.
Yeah. Okay. What if you multiplied this top equation by 3? So I would get, let me do it down here, 3 times 2, that's 6x plus 3y equals 18. Top equation times 3, 6, 3, 18. And what if I decided to multiply the bottom equation by -2? Then I get -6x minus 8y equals -8. What's going to drop out?
So you can pretty much just manipulate the numbers however you need to just get it alone.
Bingo. That's it.
Okay.
Okay. The only reason I did this one was because to me, it was easier to multiply by -4 once and I'm done. But this one, okay, if you're pretty good at multiplication, top equation by 3, bottom equation by -2, that forced my 6's to be opposite from each other. So now when you add, you get -5y equals 10. Divide, you still get y is -2. Same answer. Okay, is that kind of okay with everybody or not? Kind of, I know it's getting kind of weird. Okay, but the key was what he just said, you can manipulate this, you have control of the problem. All you want to do is make the two variables that are both x, you want to make them into opposites of each other. One's a positive, one's a negative. So I made them into 6 and -6. Or here, I wanted to make the y's opposites of each other. So this was already a 4y. So I said, if I can make that into a -4y, okay, then they'll drop out. And I don't care what happens with the rest of the numbers. If I can make one variable drop out, that's all I wanted to do. All right, let's try one more problem. Can I erase this example here? This is the same as this, just done in a different way. Can I erase this problem here?
Yeah.
All right. Okay, let's take. Okay, this has kind of big answers, but don't panic. 2x plus 3y equals 17. Use your calculator. 5x plus 7y equals 29. Maybe before we start, we should do some brainstorming. Anybody want to, what would you multiply by to make the y's drop out? If I want the y's to drop out,
The top by 7, I'm sorry, yeah, by 7 and the bottom by 3.
-3. Because you want them
Yeah,
to be
-3,
opposites.
-3,
Yeah. Doesn't matter. Yeah. You guys get that? If that was a 7, if I multiplied everything at the top by 7, that'd be 21 y. And if I multiplied everything at the bottom by -3, that'd be -21 y. And they would drop out. Now, the x and the other numbers, they go to hell. We don't know. We just got to work with that. Okay, somebody different. What if I wanted to make my x's drop out?
Multiply by 5.
Top one by 5. That'll
And,
make that into a 10. And the bottom one by
-2.
bingo, because that'll make that a positive 10x. That'll make that a negative 10x. Okay, I don't know what those will become, and I don't care. I will just want my x's to drop out. But remember, when we're saying multiply by 5, we're saying multiply everything by 5. Okay, now I'll be quiet while you guys go to work. Okay, based upon our discussion, okay, I decided to multiply the top equation by 5. So that gave me 10x plus 15y equals 85. So 5 times each of those. Okay, again, use your calculator to do the multiplication. Don't be a hero. Okay, and because that was a positive 10x, then I had to make the 5 in the other equation to be a negative 10x. So I multiplied by -2. -2 times 5 is -10x. -2 times 7 is -14. And -2 times 29 is 58. Then I add these two together, and I have forced the x's to drop out. So I end up with 1y equals, I believe this was 27, which means y is 27. Okay, now I need to plug it back in. Ugh. Neither of these are very nice equations. They pretty much suck. Okay, I guess I'll use the top equation to plug it back in. So 2x plus 3 times 27 equals 17. I'm plugging into the top. So that's 2x plus, I believe that's 81. Yeah, equals 17. Take away 81 from both sides. 17, take away 81. Clear. 81 minus 17, 64, negative. Okay. Yeah, take away 81 would be negative 64, divide by 2, negative 32. So these two together tell me that these lines would have crossed at the point negative 32, comma 27. Okay, the way I did this problem, because I eliminated my x, because I made them 10 and -10, I got my y answer first. Y was 27. I plugged it in and got my x answer next. But you always put it as x comma y. If you had eliminated the y's, then you would have gotten negative 32 first, plugged it in and gotten 27 for y. So your work would have been backwards from my work, but it would have been perfect. It would have been, there would be no problem with that. Questions? Okay. We'll pick up more of this tomorrow night. And we'll start working with, okay, what happens when there's tricks? Okay, also, shoot. I forgot. Crap. I forgot to turn it on. Maybe I can do it right now real quick. There's a worksheet well, I'll turn it on right here. Boom. Share. Let's get back into Canvas. Let's go to my modules. I want to see this as an instructor. Come on, dummy. Okay, we're in chapter 5, and I forgot to turn it on. Oops. Right here, there's a handout about how to solve 3x3 equations. It says handout.doc. It's a download. It should be it's not a doc. Okay. Anyway, I've turned it on, published it. Oops, come on. I want to publish it, you dummy. Publish it. Okay. There we go. If you have an opportunity to download it so you have it in front of you for tomorrow, that would be a really good thing. Again, it was in Canvas. Okay, it's in chapter 5. I'll have a couple things turned on. Okay, like I can turn on that one. And I'll turn on a few other things. Okay. I guess I'll turn that one on. 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 Those are all some good videos. Some I stole from people, some I did myself. Okay, so those are good things to look in chapter 5. All right, I am officially done. So where's my turn to sucker off? Okay. Stop share. Stop recording. Yes.